Good morning. Today we're going to look at the angle bisector theorem, specifically how it relates to similarity. We did an angle bisector theorem a little while ago that talked about the distance from the angle bisector to the sides. Today it's going to be more about similarity. The angle bisector theorem tells us that if a ray bisects an angle of a triangle, then it will divide the opposite side of the triangle into two segments that are proportional to the other two sides. So as you can see here, this ray, unlabeled, is bisected the larger angle because these two are marked as congruent, which means that it divides these two sides proportionally and these two sides proportionally. It is important to note, though, that these two triangles here are not similar triangles. They're in no way, shape, or form similar triangles, but they do make proportional sides. Let's see it in action. Here's example 1. Go ahead and give this a try if you'd like. Okay, so we're looking at example 1, and I noticed again that these are clearly not similar triangles. That's what I've been studying. But I do recognize that SRT and TRU are marked as congruent, therefore they're equal, and therefore I can use the angle bisector theorem. RT is bisecting SRU, this big angle. With that in mind, I know that ST here is over RS is going to be proportional to TU over RU. Substituting values in, I see that 21 over 35 will have to be x plus 1 over 15. Cross multiply, then use the distributive property. Subtract 35 from both sides and solve to get x equals 8. That is the value of x. If I needed the value of TU here, I would just substitute the 8 back in and get its value of 9. Let's try another example. Go ahead and try it on your own for a minute. Excellent. All right. So looking at this, again, like the last one, these are clearly not similar triangles, but I do recognize that angle BAC here and DAC are congruent. Therefore, AC is a bisector, and I can use the angle bisector theorem. In this case, BC over BA is going to be proportional to DC here over DA. Substituting values in, my question mark is going to represent my x, so that's x over 28. Is going to be proportional to, and here's where I had to look a little bit. CD is unknown, but so is BC. But since we called BC x, I know that 30 minus that x will give me the value of CD, so I put 30 minus x there. Now it's just algebra. I cross multiply, then use the distributive property, and continuing to solve, I find that x is equal to 21. Since BC was the question mark, BC is also 21. A third example, just slightly more difficult with algebra, but not a lot. Go ahead and give this one a try. All right, so knowing this, again, I recognize these are not similar triangles, but I do see that KJL and MJL are both marked as congruent, therefore JL is an angle bisector, and I can use the angle bisector theorem. So in this case, KL here over KJ is going to be proportional to ML over MJ. Substituting values in, again, you can see the 12 over the 18. And here, I'm missing the LM. So as my previous example, I subtracted to find the missing part. I'm going to take the 4x minus 6, subtract the 12, and that'll give me the value of LM. So you can see I just left it all there. Now, of course, I'll simplify that in a minute. So cross multiplying, 12 times 21 is going to equal 18 times, and you can see here's where I simplified. Minus 6 minus 12 is minus 18. And from there, just use your distributive property and your algebra skills to find that x equals 8. And the two missing sides would be, by substitution, Km is 21 and Lm is 9. Thanks for watching. I hope this is helpful.